homogeneous function of two variables. A function f or f(x,y) or is denoted by u is said to be homogeneous function of degree n if u expressed in the form x raised to n phi y by x, or fxy expressed in the form x raised to n phi y by x, where n is real number. Or another approach of this definition is what? If the function f px ty expressed in the form t raised to n f of xy, where again t is any real number, then we say the function fxy is a homogeneous function. So this is new approach. Uh, this approach is what? If the function fxy expressed in the form x raised to n phi y by x, some function of y by x, then we said it is a homogeneous function of degree n. Or another definition of the homogeneous function is what? If in fxy, in each term the addition of powers of x and y is same and is equal to n, then the function is called homogeneous function of degree n. For example, so this function fxy is equal to 5x raised to 4 minus 7x cube y plus 3xy. So if we check whether it is a homogeneous function, so there are three terms. So in first term, the power of x is 4 and there is no y term, means power of y is 0. So 4 plus 0 is 4. And in the second term, the power of x is 3, the power of y is 1. So 3 plus 1 is 4. And in the third term, power of x is 1, power of y is 3, and so 1 plus 3 is 4. So in each term, the addition of powers of x and y is same and is equal to 4, and therefore this function fxy is a homogeneous function of degree 4. So if we check this function, this as a homogeneous function in the next approach, then we consider fxy, take x raised to 4 common from this. So what we have? 5 minus we have divided by x raised to 4 means y by x, x cube y divided by x raised to 4 means y by x, and x into y cube divided by x raised to 4 means we have y cube divided by x cube, that is y by x cube. And so this bracket is the function of y by x. It is phi y by x, denote phi y by x, because if you observe there are three terms and each term is a power of y by x. So this is y by x raised to 0, this is y by x raised to 1, this is y by x raised to 3. So this bracket is a function of y by x. And so we say that this expressed in the form x raised to 4 into phi y by x, and therefore this function fxy is a homogeneous function of degree of 4. And the third approach, that is now there are three approaches or three definitions of homogeneous functions. So what are that? If the addition of powers of x and y in each term is equal to n, then the function is called homogeneous function of degree n. And if the function fxy expressed in the form x raised to n phi y by x, then we say the function fxy is a homogeneous function of degree n. And the another approach is what? If f of tx ty is expressed in the form t raised to n f of xy, then we say this fxy is a function of homogeneous function of degree n. So by using that definition, we have f of tx ty. From this we have to find f of tx ty, that is replace x and y by tx and ty. So we have 5 tx raised to 4 means t raised to 4 x raised to 4 minus 7 x cube, replace y x by tx. So we have tx cube means t cube x cube, t cube x cube, and y is ty, replace y by ty. So t cube and t becomes t raised to 4 x cube y. Then substitute this x as tx and this y as ty. So tx and ty bracket cube means t cube y cube. So t and t cube becomes t raised to 4 xy. So take t raised to 4 common. What we have? 5x raised to 4 minus 7x cube y plus 3xy square. And this is fxy, function fxy. What is fxy? Fxy is this. So this bracket is the fxy. And so we have value of f of tx dy is equal to t raised to 4 f of xy. And therefore this expressed in this form, that f of tx dy expressed in the form t raised to n f of xy. And therefore this fxy is a homogeneous function of degree 4. So we can check whether the given function is homogeneous by using three approaches. Either check whether the addition of powers of x and y in each term is equal to n, or whether fxy expressed in the form x raised to n phi y by x, or we can check whether f of tx dy expressed in the form t raised to n f of xy. So we have three definitions, three approaches to check the given differential equation is homogeneous or not homogeneous. So next example is u or fxy is equal to x raised to 5 plus y raised to 5 divided by x raised to 3 plus y raised to 3. We have to check this is a homogeneous function. So first, by using the first approach, that if we take u is equal to take x raised to 1 by 5 as common. So what do we have? So here write x raised to 1 by 5 before the bracket is equal to, in bracket x, if you take x raised to 5 common, then we have at this place 1 plus y by x raised to 1 by 5. So y raised to 1 by 5 divided by x raised to 1 by 5 means y by x raised to 1 by 5. And if we take x raised to 1 by 3 common, right here x raised to 1 by 3. So we have in bracket 1 plus y raised to 1 by 3 divided by x raised to 1 by 3 means y by x raised to 1 by 3. And then in the next step, x raised to 1 by 5 divided by x raised to 1 by 3 is x raised to 1 by 5 minus 1 by 3. Cancel this x raised to 1 by 5 and 1 by 3. In bracket we have this. And then 1 by 5 minus 1 by 3 is x raised to minus 2 by 15. Take LCM 15, and then 3 minus 5 is minus 2. And this remaining is the function of y by x, and suppose phi y by x. And therefore what we say that u or fxy expressed in the form x raised to minus 2 by 15 phi y by x. And therefore this u or fxy is a homogeneous function of degree minus 2 by 15. And we can check this function as a homogeneous function by next approach. So find f of tx dy, the value of f of tx dy. So it is what tx, replace x by tx and y by ty. So we have tx raised to 1 by 5, ty raised to 1 by 5, then tx raised to 1 by 3, ty raised to 1 by 3, plus, right, plus sign. Then take t raised to 1 by 5 common. So this tx raised to 1 by 5 means t raised to 5 x raised to t raised to 1 by 5 x raised to 1 by 5. Here is t raised to 1 by 5 y raised to 1 by 5. Take t raised to 1 by 5 as common. So we have x raised to 1 by 5 plus y raised to 1 by 5. This tx raised to 1 by 3 means t raised to 1 by 3 x raised to 1 by 3. This t raised to 1 by 3 y raised to 1 by 3. So take t raised to 1 by 3 as common. So we have x raised to 1 by 3 plus y raised to 1 by 3 in bracket. And so t raised to 1 by 5 minus divided by t raised to 1 by 3 means t raised to 1 by 5 minus 1 by 3. And 1 by 5 minus 1 by 3 is minus 2 by 15. And this bracket is f of xy. So what we say that f of tx dy expressed in the form t raised to minus 2 by 15 f of xy. And therefore f of xy is a homogeneous function of degree n is equal to minus 2 by 15. So we can also check whether three variable function are homogeneous functions. Same type problems is here. F of u or f of xy is equal to x raised to in root x raised to half plus y raised to half divided by x raised to 1 by 3 plus y raised to 1 by 3. Now we have to check whether this is a homogeneous function. So we will find this is uxy. So we have to find u of tx dy or f of tx dy. If we denote this function as fxy, then we find f of tx dy, u of tx dy. This is uxy. is equal to replace x by now tx and y by ty. So tx raised to half means t raised to half, x raised to half. Then y is ty. Ty is what? T raised to half, y raised to half, plus tx raised to 1 by 3 is t raised to 1 by 3, x raised to 1 by 3, plus ty raised to 1 by 3, t raised to 1 by 3, y raised to 1 by 3. Then take t raised to half common from this root. So it becomes t raised to half or root of t. Root of t raised to half. That is t raised to half means t raised to 1 by 4. If we take t common from root, we have t raised to half. If we take t square common from root, then it becomes t raised to 1. Like that, if you take t raised to half common from root, then it becomes t raised to half or root of t raised to half. And root of t raised to half is t raised to 1 by 4 in bracket x raised to half plus y raised to half. Similarly, we take t raised to 1 by 3 common from this root, and so it becomes t raised to half raised to t raised to 1 by 3 raised to half, or we have root of t raised to 1 by 3, and root of t raised to 1 by 3 means t raised to 1 by 3 raised to half means t raised to 1 by 6. In bracket we have t x raised to 1 by 3 plus y raised to 1 by 3. Then t raised to 1 by 4 divided by t raised to 1 by 6 is t raised to 1 by 4 minus 1 by 6, because we know that x raised to m by x raised to n is x raised to m minus n into this as this quantity as it is. And then t raised to 1 by 4 minus 1 by 6 is 24 LCM, 6 minus 4 that is 2 by 24, that is 1 by 12. So we have t raised to 1 by 12, and this function as it is, the root x raised to half plus y raised to half divided by x raised to 1 by 3 plus y raised to 1 by 3. And this is the uxy, t raised to half in root t raised to half plus y raised to half divided by in root x raised to 1 by 3 plus y raised to 1 by 3. This is uxy or u. And so what we have? We have utxty is equal to t raised to 1 by 12 uxy. And so by using the definition of homogeneous function, it is a homogeneous function. This u or uxy is a homogeneous function of degree 1 by 12. So we have to solve these problems by using same method. Next problem. Suppose u, the given function is function of 3 variables. So u r is equal to f of x, y, z. Then if it is expressed in the form x raised to n, function of y by x into z by x, then we say it is a homogeneous function of degree n in variable x, y, z. So homogeneous function of 3 variables. So same method. The method, the definition for 2 variable is what? If u express in the form x raised to n function of y by x. In the place of that, if uxy z or fxyz expressed in the form x raised to n function of y by x, comma z by x, then we say it is a homogeneous function of degree n in xyz. Or we can define this definition in the another form, that is, if this when we fxyz is called homogeneous function, if f of tx, ty, tz expressed in the form t raised to n f of xyz, then we say that this function fxyz is a homogeneous function of degree n. So the example, fxyz is equal to 3x cube, or we can also given the definition of the homogeneous function as homogeneous function of 3 variables as fxyz is called homogeneous function of degree n in xyz if the addition of powers of xyz in each term is equal to n. So for example, this function fxyz is equal to 3x cube plus y square z plus z cube. This is a homogeneous function of degree 3 because there are 3 terms, and if you observe the first term, the power of x is 3, power of y is 0, power of z is 0, and so addition of powers of x, y, z is 3. In the second term, power of x is 0, power of y is 2, power of z is 1, and therefore addition of x, y, z, powers of x, y, z is 3. In the last term, the addition of powers of x, y, z is 3. So in each term, the addition of x powers of x, y, z is equal to 3, and therefore this f x, y, z is a homogeneous function of degree 3 in three variables, obviously x, y, z. So is a homogeneous function of degree 3. Or we can check whether this is a homogeneous function by using this definition. That is f of x, so take x cube common. So what do we have? 1 plus y by x bracket square z by x, because y square z divided by x cube. So we can write divided by x cube as x square into x, and then we have y by x square z by x plus z cube divided by x cube is z by x cube. And so if you observe this bracket, it is a function of phi y by x z by x. It is a function of y by x z by x, and we have f(x, y, z) is equal to x cube phi y by x comma z by x, and therefore we say this f(x, y, z) is a homogeneous function of degree 3. Now, we can also check by using this definition, that we find f of tx, t by tz, that is replace x by tx, y by ty, and z by tz. So we have t cube x cube plus here we have t square y square into tz, and this t cube z cube. So replace x, y, z by tx, t by tz, we have this, and then take t cube as common. We have 3x cube plus y square z plus z cube, and this bracket is the function f(x, y, z). So f of tx, t by tz expressed in the form t cube f of x, y, z, and therefore f(x, y, z) is a homogeneous function of degree 3. So this is the another example of three variable u or f(x, y, z) is x plus y plus z divided by root x plus root y plus root z. So if you observe, the numerator is the homogeneous function of degree 1, and the denominator is the homogeneous function of degree half, and therefore the degree of this total function is 1 minus 1 half, that is 1 half. So there is a formula that if the degree of numerator is m and the degree of denominator is n, then here the formula degree of f(x) by gx is degree of f(x) minus degree of gx. So like logarithmic function, log of a by b is log a minus log b, like that. Degree of f(x) by gx is degree of f(x) minus degree of gx. So if we apply the definition for this example, then numerator is degree of half, and the denominator is the degree of its degree is 1 by 3. Numerator is a homogeneous function of degree 1 half. Denominator is the homogeneous function of degree 1 by 3, and so not 1 half, 1 by 4. The degree of numerator is 1 by 4, and the degree of denominator is 1 by 6, and so the degree of whole function u is what? 1 by 4 minus 1 by 6, that is 1 by 12. So observe this example, f of x, y is equal to x plus y plus z. So take x as common from numerator. We have 1 plus y by x plus z by x. Take root x as common. So 1 plus root y divided by root x means root y by x. Root z divided by root x means root z by x. And so x raised to half divided by x raised to 1 divided by x raised to half is x raised to 1 minus 1 half. By using rule, x raised to m divided by x raised to n is x raised to m minus n. X raised to 1 divided by x raised to half is x raised to 1 minus 1 half, that is 1 half. And the remaining is what? Is the function of y by x and z by x. And so we can express u or f(x, y) as x raised to half pi y by x, z by x, and therefore this u or f(x, y) is a homogeneous function of degree half. Or we can also take f of tx, ty, tz. This is f(x, y, z). So we will find f of tx, ty, tz is what? Replace x, y, z by tx, ty, tz. So is tx plus ty plus tz divided by root th, root ty plus root tz, and that is take t raised to half common from t common from numerator, and t raised to half or root t common from the denominator. So t divided by root t is t raised to half, and the remaining is the function of x, y, z, and therefore we can verify, we can have that the function f x, y, z is a function, homogeneous function of degree half. So some examples. So if we observe this example, f x y is as y plus root x square plus y square divided by x, then we observe numerator is a homogeneous function of degree 1, and the denominator is a homogeneous function of degree 1, and so the degree of this whole function f x y is 1 minus 1, that is 0. We will check by using third approach, that f of, we will find f of tx ty. So is ty plus root t square x square plus t square y square divided by tx. So how we can find the value of f of tx ty? Just replace x and y by tx and ty. So is ty plus the root, take t square common from root, we have t common. So after taking t square from root, we have t in bracket x square plus y square divided by tx. Then take t common from numerator, we have y plus root x square plus y square divided by tx. T get cancelled. So we have y plus root x square plus y square divided by x, and that is, it is t raised to 0. T raised to 0 is 1. So it is t raised to 0 in bracket y plus root x square plus y square by x. That is, we have t raised to 0 f of xy. This bracket is f of xy. F of xy is this. So f of dx dy expressed in the form t raised to 0 f of xy, and therefore fxy is a homogeneous function of degree 0. Similarly, if we take y plus root x square plus y square, separately this, then f of tx dy is ty plus root t square x square plus t square y square, and therefore we have ty plus t root x square plus y square. After taking t square common from root, we have t outside the root divided into root x square plus y square, then take t common. So we have t raised to 1 y plus root x square plus 1, that is t raised to n f of xy. This is f of xy, and so this f of xy is equal to y plus root x square plus y square is a homogeneous function of degree 1. Similarly, f of xy is equal to y minus x tan y by x. So f of tx ty is ty minus tx tan ty by tx. Tt get cancelled, so we have tan y by x, and take t common, we have t in bracket y minus x tan y by x, and this y minus x tan y by x is f of xy, and therefore we say f of xy expressed in the form t raised to 1 f of xy. So this y minus x into tan y by x is a homogeneous function of degree 1. Similarly, f x y is equal to 2y minus 2x minus y e raised to y by x. Then find f of tx ty. It is 2tx minus ty e raised to ty divided by tx. That is, replace x by tx and y by ty. Then take t common. We have 2x minus y, and tt get cancelled, so e raised to y by x. So we this is the f of xy, and so we have f of tx ty is t raised to 1 f of xy. So f of xy is a homogeneous function of degree n. Similarly, if you take y plus x e raised to y by x, then f of tx ty is ty plus x, means tx e raised to ty by tx. Tt get cancelled and take t common. We have this, and therefore fxy is a homogeneous function of degree n. So if you take the division of this 2x y by e raised to y by x and divide by y plus x e raised to y by x, then it is this numerator is a homogeneous function of degree 1, the denominator is a homogeneous function of degree 1, and the degree of this whole function is 1 minus 1. So we will check independently, that is f of tx ty is equal to, replace x and y by tx and ty. So we have this, and then take t common, tt get cancelled, take t common and tt get cancelled, we have this, and the t by t is 0, t by t is 1, then we have 2x minus y, and that is the function fxy. So we have t raised to 0 f of xy, and therefore fxy is a homogeneous function of degree 0. So degree of fx by gx is degree of fx minus degree of gx. So when fx by gx is a homogeneous function, if both fx and gx are homogeneous functions. So we'll solve these problems. F of xy is x root x square plus y square minus y square. If we find the f of, this is a homogeneous function of degree 2. So we can check, find the f of tx ty is tx t square x square plus t square y square minus t square y square. Then take t square common from this root. We have t outside the root into x square plus y square, and this t into t is t square x root x square plus y square. Then take t square as common. So we have x root x square plus y square minus y square, and this is the f(x,y). So f of t x dy expressed in the form t square f of xy, and therefore this is a homogeneous function of degree 2. So these are problems for homework. Check whether which of the following is homogeneous function. Check whether these are homogeneous functions, and if these are homogeneous functions, then find its degree. So the answers is given. This answer of this 4-number problem is also given here. How we can check the function is homogeneous function? Find f of tx ty, f of tx ty, or for these two problems, find f of tx ty tz, and if it is expressed in the form t raised to n f of xyz, then we say it is a homogeneous function of degree n. So solve these problems. Answer are given. So while solving the homogeneous differential equation, this topic is important, that we have to check whether the given differential equation is homogeneous differential equation. When the m dx plus n dy is homogeneous differential equation, the homogeneous differential equation, so observe these problems. So here y plus root x square plus y square is a homogeneous function of degree 1 divided by x is a homogeneous function of degree n. So this y plus root x square, how we can check this y plus root x square plus y square is a homogeneous function? If we find f of tx ty, then this is what? T raised to 1 f of xy. Okay, so this y minus x tan y by x is a homogeneous function of degree 1. So how we can check this y sin y by x minus x is a homogeneous function of degree 1. This x into sin y by x is a homogeneous function of degree 1. So how you can check this for a homogeneous function? If you consider this y into sin y by x minus x as fxy, and if we find the f of tx ty, then it is t raised to n f of xy. So this is a homogeneous function of degree 1. Similarly, this 2x minus y e raised to y by x is a homogeneous function of degree 1. Y plus x e raised to y by x is a homogeneous function of degree 1. So this x in bracket root x square plus y square minus y square is a homogeneous function of degree 2. Okay, so in order to check these m and n are homogeneous functions of degree, are whether homogeneous functions or not homogeneous functions, this topic is important. That so this is important. So this y plus root x square plus y square is a homogeneous function of degree 1. So if we check whether this y plus root x square plus y square is a homogeneous function, find f of t x t y is what? T raised to 1 f of x y. So this y plus root x square plus y square expressed in the form t raised to 1 f of xy. So this is a homogeneous function of degree 1. Divided by x is a homogeneous function of degree 1. So degree of this whole function is 0. Degree of numerator is 1, degree of denominator is 1, and so degree of uh, whole function is 1 minus 1, that is 0. So y minus x into tan y by x. So it is again a homogeneous function of degree 1. How we can check? We can find f of t x t1. It is t raised to 1 f of x1. And therefore, so these are the homogeneous functions. So in order to check whether the given differential equation is homogeneous differential equation, we have to check whether m and n are homogeneous functions of same degree, because the definition of homogeneous function is what? If when m dx plus n dy is called homogeneous function of degree, yeah, homogeneous differential equation, if m and n are both are homogeneous functions of same degree. So this is about the homogeneous function and its degree. So in the next lecture, we'll solve the remaining problems.